Hello. In this video, I want to talk about permutations and combinations and the concepts behind them. So first, let's define them. So combination in math just talks about how many different combinations can you make. And in a combination, the order does not matter. Permutations are just like combinations, except in permutations, the order matters. The way we write them or do the notation for them, for permutations, we have n, where n is the number of items, and then r, where that's how many things we're actually picking in our permutation. Same thing for combination, same letters, we just use a C for combination instead of a P. So let's start by taking a specific example and working from there. Let's say we've got 4 people and 3 seats. Okay. Now over here the order matters. So if we're trying to figure out how many different combinations of people we can get where the order matters, we're going to use a permutation. Now the quickest way to do a permutation is by using the fundamental counting principle. That says that if we want to know the total number of possibilities, we multiply each number of possibilities for each situation. So for the first seat, there are 4 different people that can sit there. Now the person that's sitting there can't sit in the second seat at the same time, so there are 3 different possibilities for the second seat and 2 different possibilities for the third seat, for a total of 24 different permutations. Now you could go through and list every single permutation there is. That takes a little bit of time, but I did do it right here. Now the reason why I did this is I wanted to show the difference in a permutation and a combination using this table. And so here is what I did. I took the numbers, and if you'll notice this top line right here are unique combinations. Okay, 1, 2, and 3 is different than 1, 2, 4, is different than 1, 3, 4, is different than 2, 3, 4. The other direction is where I took and I just mixed up the numbers. So if we go this way, I didn't mean to use that color, but it'll work. If we go this way, those are just the same 3 numbers mixed up. Alright, so if we think about it, if we figured out how many different ways we can mix the numbers up, we can go from a permutation to a combination. And so let's think about it. If we've got 3 chairs, how many different ways can we arrange those 3 chairs? Well, in the first chair, there's 3 different possibilities for that chair. In the second one over, there's 2 different possibilities. And then for the last chair, there's only 1. Okay, so once again, counting principle gives me 6 different possible ways we can arrange those chairs. Alright, so to figure out how many unique combinations there are, we just take and we divide the number of permutations by the number of possible ways to mix up the numbers, and we get our answer. Okay, so we've got 24 for the permutation answer and 4 for the combination answer. Alright, so that's one way you could think about this and reason through it and get your answers. But let's try to make a formula from this. In order to do that, we've got to use a generic case. So here we've got n people and they're sitting in r chairs. Okay, so we've got person 1, person 2, person 3, person before n, and person n, with everybody in between in there. We don't know how many there are. That way we can use this and apply this formula later on to any situation we get, as long as the number r is less than the number n. Alright, so here we have the number of chairs. Okay, first chair, second chair, third chair, chair before r, chair r. So let's see how many different permutations there are. Okay, so the number of possibilities for the first chair is n, for the second chair is n minus 1, third chair is n minus 2. And where I get these numbers from, there's one fewer person to sit in the second chair. There's one fewer possibility than that for the third chair. All right, all the way down to there's, in this last chair, it's going to be n minus r because there's only r chairs. All right. Oh, my bad, not n minus r. N minus r minus 1. Okay, because if you notice, where we get this number from is we subtract 1 from the number below it. Okay, let me put some parentheses around this real quick. So this one right here would actually be n minus r minus 2. All right. Now, looking at this, if I wanted to find the total number of possibilities, I would multiply all those things together. So we've got n times n minus 1 times n minus 2 times dot dot dot, lots of stuff in the middle, times n minus, now I don't like putting parentheses inside of parentheses when I don't have to, so let's distribute that negative. So we've got minus r plus 2 times n minus r plus 1. Alright, that's not helping us figure out a formula just yet, because I've never really seen anything quite like that. But if we look back at our previous example, we have 4 times 3 times 2. That's almost what we call a factorial. 4 factorial is 4 times 3 times 2 times 1. So, I'm going to try to make this a factorial. Now, the problem is, I can't just go through multiplying by more numbers because that would change the value. Luckily, I know a trick. If I multiply by something and then immediately divide by the same thing, it's like I multiplied by 1, and it doesn't change the value. So, that's what I'm going to do. I'm going to multiply by something over here, and then I'm going to divide the whole thing by that same thing. Alright? So, the next thing down, if I wanted to make this a factorial, I would go down one more. So that's going to be n minus r. Okay, and then the next thing is going to be n minus r minus 1, and then times dot dot dot, and then eventually we'll get to times 3 times 2 times 1. Okay, so since I multiplied by that, I also have to divide by it so I don't change the value. So we've got n minus r minus 1 times dot 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 times 3 times 2 times 1. Alright, so on the top now, that is the same thing as n factorial. We start at n, we go all the way down to 1. On the bottom, this is n minus r factorial, because we start at n minus r and we go all the way down to 1. Cool. So, now the only thing we have to do from there to get to combinations is figure out the different ways we can mix these things up here and then divide by that number. Alright, so for a combination we do the exact same thing. We've got the n factorial over n minus r factorial, but we also have to divide by the number of different combinations in the bottom. Now if you notice, in the combination part earlier, we just did 3 times 2 times 1 because we used all the different r's there. So that's what it's going to be. It's just going to be r factorial. That's how many ways you can mix those things around. So if we divide by that r factorial there as well, we get our final answer. So there is your formula for combinations, and there's your formula for permutations. Okay, let's just write them out quickly in a different color, and That would be pretty much it. So if we've got n items and we're looking for a permutation of r items, okay, what we did was we took n factorial on the top, and we divided that by n minus r factorial. For a combination, we took our permutation, our n factorial over n minus r factorial, and then we divided that by r factorial. And when you divide by a number, you can just put it in the denominator as well. And so those are our two formulas. Hope this helped. Have a good one.